Hey folks, how's your week been?
Good.
Good? Okay, good to hear. Better than mine, I hope. How have people been getting along with the lab from last week? I know a few of you emailed me or posted that you wanted some time today to work on it. Is that a lot of you? Hands up. Okay, seems like a sizable amount. That's fine. We'll try finish up early today. And just to reiterate, the point of lab every Thursday, not Friday, Thursday, the point of lab is to have you guys work together, meet each other, and collaborate. And so I ask that when the presentation's over, you folks stick around so that you can get the most out of it. Obviously, I can't stop you from leaving after you've checked out, after you've checked in. But the only way you're going to meet people to work together is by staying here. And also the only way you're going to learn to grow as developers is by asking questions, coming up to the front. Luke and I and Natalia, can't see her right now, are always willing to help you. So keep that in mind. So today, you guys are going to graduate from taking your first steps into Solidity, syntax, this new language, and actually building your very first smart contract. And today what we're going to do is we're going to talk about the tools we're going to use to do that, and how it's done professionally, how you test, how you build, your workflow. And then I'm just going to give you guys a bunch of docs and an exercise to do. And that's when you can choose, for those of you who are done, you can choose to move on to the new exercise. And for those of you still working on last week's, you're free to continue working on that. Okay, so who's familiar with these frameworks? Okay, cool. Can anyone talk about their experience a little bit?
Like MVC framework, you have the model view controller.
Yeah, so what is the model view controller?
Like model basically is like data.
So you have this segmentation of different roles in your prototypes, in your products, and you really wanna kind of abstract things away into the model view controller. The way this happens in the decentralized world, and we're lucky to be building on the Ethereum platform in 2018 because a year ago these tools didn't exist. So today you have frameworks like Embark. You'll most often hear about Truffle. And under Truffle, you have Ganache, which is the one to your very right. And what Ganache is a blockchain simulation tool. So you have your very own mini blockchain running on your local machine. You don't need to download gigabytes of blocks. You can just go ahead and do that instantly. And I'll hopefully be able to give you guys a demo of that. Outside of that, Truffle itself is a framework that sets up a lot of boilerplate code. Who knows what boilerplate code is?
The code which comes to the framework just to minimize your work to start.
Yeah. So with any sort of this happens a lot in full stack development, where you have to go ahead and set up certain directory structures in order for certain frameworks to understand where to locate things. And what has happened in recent years with things like with Node.js and now Truffle.js is that they've started to automate the boilerplate code. So everything is very nice. It's done for you. And what you'll find is that you'll have this directory structure set up when you call Truffle init. So what I want to have happen now is if you folks, who doesn't have Truffle set up on their local machines? Okay. That was assignment 0 from the very first week. So if, just for now, could you work with someone who does have Truffle installed? And what I want you folks to do is I want you to go to your terminals Can you guys see that? Okay. Okay, and anywhere you want, just make a new directory. Right, and cd into it. So now we're in this new directory. And if you've got Truffle installed, hopefully you'll be able to call Truffle init. And you'll have these three things, right? These three main things: contracts, test, and migrations. Now, is any of this intuitive at all? What just happened? Can anyone explain? Yeah, so this is the boilerplate code we were talking about just a minute earlier. Does anybody know what goes into each one? So, like, what would you put in contracts? Right? Smart contracts. Your logic, basically. What would you put in test? Okay. What would you put in migrations? Your migrations? Okay, so what are migrations, right? The other two are intuitive. Migrations are ways of doing version control, basically, on the blockchain. Because if you think about it, you deploy your product today on Ethereum. Your needs change tomorrow. And as a business, you need to adapt with the market, with your own customer base. But you've already deployed the smart contracts, right? And what do we know about blockchain? It's immutable, right? So how do you change the inner functionality of your product? How do you add a security layer if you discover a bug or vulnerability? Does anyone have any ideas? A hard fork of the entire network?
You like point people to a new contract?
Yeah. So actually, you're both correct. Not exactly a hard fork, but yeah, exactly. So you have this initial deployment contract that points to your most current version, right? Just like Git points to the head of your branch, your working branch. And so you deploy a contract to keep track of all your other contracts. And as you deploy updates, this contract shifts its pointers to point to the new contracts, basically. So every time you have to update a new version, you'll just deploy another contract. Does that make sense? Yes. Right. So do you want to guess? The question was, what happens to the old contract?
It stays there.
It just stays there. So you have to make sure that nobody's running a deprecated version of your software, right? Because if you discover a vulnerability in your old software, and you still have customers running your old software, that's a problem. Any questions so far? Okay, cool. And so, what if every business went onto Ethereum and started deploying smart contracts every time they had an update? Would that be an issue or no? Just give it a guess.
Yeah, it would be a problem. They'd have to tell everybody.
Yeah, and also you clog up the network and you have to pay for storage, and nobody wants to do that. Deployments become expensive eventually. And so ideally, you want to test in a local environment. And that's what we learned about testnets for, because it's very, very cheap, very, very easy to run simulations of your business on testnets before deploying to the real thing. And what's even better than running on testnets is running locally. And so that's where we're starting today. And so you can see the chain of progression that you guys will hopefully make over time. Any questions about the directory layout? Cool. Okay, so these are the commands for if you haven't installed Truffle or Ganache. I recommend Ganache CLI, the command line interface. Very, very cool, very, very useful. Hands up, anyone who still needs this on the board. Awesome. Okay, so before we move on, I've already prepped a Truffle directory, and if we go into contracts, we'll see that we've got our trusty old, we've got our trusty old greeter contract. Does anybody remember what the greeter does? Returns the greeting, right. So this is what it looked like last time, right? You did it in Remix. By the way, what are your thoughts on Remix? Does anybody want to share? Intuitive, easy to use, bad, ugly?
I think at first it's a little bit difficult to learn, but like I felt like the more I used it, the more I feel like I feel comfortable with it now, and now I'm comfortable with it, I'm like really expecting it to understand, and then I have to set up an environment like outside of the project.
Awesome. Glad to hear that. Okay, so we're not going to break this down line by line, but does anybody want to give a quick summary of what's going on here? Yes. Yep. So what is the first line? Pragma solidity. What does that mean?
Choosing the version to use.
You're choosing which version to use. Right. Does anybody know what the latest version is? 20, right. Okay. So you choose what version to use, and then what? What's the next step? Really? Okay, so what's the next step?
Starting the contract and defining.
Yeah, it's right there. You open up a new contract as you define a class in Python. You give it a name, in this case greeter with a capital G. And then you enter the body, right? You open up curly braces and you enter the body. And in there, we're defining a private string greeting, right? What does private mean in this case? No other contract can change it. Raham? Okay. And a quick reminder, is anything really actually private on the Ethereum blockchain? Okay. Okay, and then you have this other function, capital G greeter, which coincidentally has the same name as the contract. What does this do? The constructor, right? It runs once on deployment and never again, right? And so how would you instantiate, how would you let the contract know who its owner is, right? Where would you put that little piece of logic?
Isn't it like the person who calls function,
Right, so on deployment, the constructor runs automatically without you having to do anything, right? And it'll only run once. And the message that gets sent to the contract holds the address of the person who deployed it. And so it makes sense to instantiate the owner within the constructor, because after that, nobody else will ever be able to call it again. And that's ideal, because you don't want the owner being reassigned somewhere down the line, unless the owner chooses to do that. And you can build in functionality for that as well. Okay, so I think we're good here. There's also a function called greet, which returns the greeting. And we see that it's got a few modifiers. Public, it returns a string, but also it's got this new modifier that we haven't seen before, view, right? Can anyone guess what view means?
That function doesn't change in state, it's only just a few things.
Right, so view is now a replacement for constant. If you recall constant from last week, view is used to indicate to the compiler that, okay, this function is not going to change anything. It's not going to change the state of the contract. Yes?
Solidity, what's like the distinction between like a getter method and just like a public variable?
What's the distinction between a getter method and an instance variable?
Like a public variable.
Right. So implicitly, I think the EVM builds in the getter methods. So if it sees a public variable, it'll have that functionality there. So you'll be able to call an implicit function to get that back. Now, why do you still want to include a getter method, though, for that variable? Exactly. You're working open source, right? And so you want people to be able to see how to do things. Okay. So moving on to development, what are we going to do here? So first up, you open up a new terminal, and let me know if I'm going too fast or going too slow. And we can say, okay, wow, boom. A lot happened just there. Maybe I should zoom out. Cool. So what's going on here? What did we just do? Can anyone guess? So we talked about how Ganache is this local simulation of a blockchain. And to be useful, right, to be able to interact with the blockchain, you need accounts. And you need Ether, right? So basically, Ganache has gone ahead and generated for you a bunch of accounts with a bunch of private keys that correspond to those accounts. So if you want to do some cryptography, you can do that. If you just want to do some transactions, you can also do that. And most useful of all, if you want to deploy contracts onto this local network, you can do that. And what's interesting is that when you close the instance, everything disappears. Which is quite convenient, because it means that you're not clogging up any of the network. You're not paying for storage over time. Does that make sense to everyone? Awesome. Okay, so how do we interact with Ganache? Right? Okay, so I actually, it won't let me type anything. But it does say listening on localhost 8545. Don't worry about what that means too much for now. It just means you need to configure Truffle a little bit. And so I'm in the same folder right now, and what I want to do is, with all my contracts in the contract directory, and if I have tests, put them in the test directory. But after doing all that, I want to run Truffle Migrate. So I can actually migrate all of my contracts and all the changes to my contracts onto this new instance of the blockchain.
Can you repeat that?
Yeah, so your contracts don't start off on the blockchain, right? On this Ganache blockchain, which is just a clone of the Ethereum blockchain, a local clone, you can say. And you need to get them on there so you can interact with them. So that just entails pushing your code base onto there. And if you observe Ganache, you can see there's been some activity. There's some activity here that wasn't there before. And you can ask for... Oh, it's fine. You can see it on your own local screen as well. Yes?
So I downloaded Ganache, but I can only open it in like a user interface thing.
Mhm.
Not the command.
So you should go ahead and... The user interface is fine. I prefer the CLI just because it's faster.
I can't use the command Ganache CLI.
You cannot.
Yeah.
Did you download the command line interface?
So it's separate from
It's separate, yes. Yeah. Yes.
So mine says it's listening, but when I try to do the migrate, it says writing artifacts and it says no network specified, it's not determined for a network.
Yeah. So the reason for that... Where did I... So the reason for that is that you need this in your config, your truffle.js, which is in your root directory. You'll just need a JSON that points Truffle to that port, 8545. So it's going to direct all the traffic there. Okay. I'll leave that up for a little bit. Does anybody else have questions? We haven't done anything so far. Yes? So ideally, you run all your Truffle commands in your root directory. The root directory is the directory you typed Truffle init. So it's the directory you instantiated your working environment. Yes?
Does Truffle Migrate just execute all the migrate scripts?
Yeah. So that's step 2. You need to add all your contracts, any contracts that you may have in the contract folder. You need to make sure that they're in the migrate script so they can be migrated over. And we'll see how to do that in a second. Any other questions? Okay, if you haven't gotten it so far, don't worry. We'll return to it. If you look in your migrations folder, you'll see that there's a script called one_initialmigrations.js. This is where, well, right now, you should only have a single line at the top saying var migrations equals artifacts.require migrations.sol. And .sol is, of course, the extension for Solidity files. So what you want to do is you want to use this JavaScript syntax. This file is in JavaScript. And you want to require all the contracts that you want to include in this project. So right now, I don't know if any of you have working contracts already, but in the future, this is what you're going to have to do. Heads up. Don't worry about doing it for now. I'll drop a repo, and you guys will all be able to clone it and work within it. Okay. So once we've got all that working, say we've migrated everything over to our local blockchain. What do we do next? Is that it? Job done? Well, for starters, we haven't even, perfected our contracts. How do we test them? But how do you write tests for them? Well, how do you even interact with them in the first place? They're in this fourth dimension that you can't really interface with, right? Okay, so that's why you have the Truffle Console. See that? Okay. So now you're in this you've broken through into this weird environment, and you have access to a lot more functionality than you did before. For example, you can query Web3. So what just happened there? Who can give me a guess? What does that look like? What's that? A hash? Perhaps? Right. So, if we compare this and go to Ganache and look at this, it matches that exactly. So now we have access from our console. We have access to the accounts. Right? Cool. What do we do with them? Well, that's not the only thing we have access to, though. So if we type in compile, let it go for a second, and then go ahead and perhaps what am I doing here? Right. So hopefully by now, my contract called greeter has been deployed onto Ganache, and I can hopefully create one and then work with it, right? Pretty intuitive stuff. Why am I passing in hello? Why does that make sense? Yeah. So the constructor, if you recall, takes in a parameter underscore greeting. And that's what I'm doing right here. Yes?
So this next new method called constructor.
Mm-hmm. Right.
How do you unpack greeter dot greeting or whatever your constructor is?
Yeah. So right now, we don't have an instance of the contract to work with.
Okay.
And that's what this is going to do. It's going to deploy contract.
It's basically looking at the local compiled greeter contract.
Yeah.
Okay.
Yeah. So greeter points to a known address space. So it's going to go to that address space, grab all the bytecode, and build a contract out of it for the user to interact with. Any other questions?
So when you press enter here, it's going to create a greeter contract with the string hello.
Awesome. Yes. Thinking ahead. So actually something magical happens. Okay. What the heck? So I could scroll up for a fair bit here. Yeah, so this is my last command, and this just shows you the messy version of what the contract looks like now. The important part you need to take away here is the address, right? And why do you need the address? Exactly. So you're going to say, okay, there's a greeter at this address, right? So I'm referencing it. But what do I want to do with it? There you go. Cool. So you've now interacted with your first smart contract. Were you guys expecting more? Sorry to disappoint. So the nice thing about this is that you don't have to, right? You can deploy for free. Your computer is not going to charge you fees. But given that you brought up an important point, right? If you want to test a product on the Ethereum network, you want to be able to work within the confines of the Ethereum network itself, right? So how do you send transactions to other people on this local network? Like if I'm building a bank app, why is this useful to me? Yeah, but if I can just deploy for free, I'm not facing like the real world circumstances that I would encounter out in the wild, like out in the main net, right? And in a sense, yeah, that's right. You're not actually going through the difficulties of mainnet development. But we're also learning here, and this is a great tool. And it's not too far removed from reality, because you can actually create fake ether and distribute it between your accounts. So forget how many accounts are actually instantiated. So 10. You start off with 10 accounts, so you have 10 fake users on your network. And you can call each one and see how each user would respond in different situations. Now, these aren't real users. There's nobody behind the scenes, right? But you can play the role of 10 different users on the network. And you can add more. So 10 is somewhat of an arbitrary number. You can create more private keys and whatnot. But the beauty of this is you can test out some very, very interesting game theoretical simulations, right? In our security lecture, we're going to talk more about exploring different paradigms, right? Simulating different behaviors. Okay, so I have this one person who is constantly trying to spam a certain contract. How can I build my contract to defend against it? And so you can take on the role of, you can't see it here, but they're actually labeled 0, 1, 2, 3, 4, 5. So the first one is 0, and that's generally the main user. You'll take on the role of 0, but you also take on the role of 1, right? And as 1, you're going to try and attack the contract that 0 has deployed. You're going to try and steal away ownership of the contract that 0 has deployed. And you can imagine how things can get a little bit messy here and there. You can instantiate these accounts with as much ether as you need to get them to do their jobs. Who's not clear on that? Any questions? Right. For now, the best thing you guys know how to do is to interact directly through the console. Soon we're going to teach how to write tests, but don't worry about that for now. Okay, so that's actually the end of the lab. Surprise, surprise, to tell you we're going to finish a little bit early. What you guys have to do now is, if you remember all the work you did last week, what I would like you to do is I'd like you to take all of it and deploy it on your own local Ganache, right? So if you did Fibonacci, if you did the XOR, if you did the string concatenate. Who did string concatenate, by the way? I hope you all did. It was your assignment. But who did it by importing modules? Okay. Who did it without importing modules? Does anybody want to share their solution? With it.
Convert it to a byte and make a byte length, and then put strings into it, and then convert it back to strings.
Mm-hmm,
The reason we need to do that is because strings cannot be indexed into for some bizarre reason.
Awesome, awesome. Acute observation. So strings suck on Ethereum.
But the equation is not designed for storing the string anyway.
It's so when you design a Turing complete language, you have to meet certain people's expectations of how they interact with Turing complete languages. And the only reason we're complaining right now is because we've all used Python or any other language, and you know, strings are so nice to work with. But anyway, no matter how you did it, module or no module is fine. For those who didn't use the module, the way to have done it would have been to convert the two strings that you're trying to concatenate to bytes. You instantiate a new byte array of length string 1 len plus string 2 len. And then you loop through string 1, and you add in all the bytes into the byte array. And then you loop through string 2, and you add in all those bytes to the byte array. And then you convert the byte array back into a string and return it. Really, really messy. Anyway, so again, your job is going to be to port all your work over from last week into new smart contracts, deploy them on Ganache as a refresher. And then there's going to be a task for you that's a little bit more elaborate than what you've been used to. And I really feel like pushing you guys and see where we're at. To see where we're at. So let me know how it goes. Post on Piazza. Come ask me questions. The link will be up on Piazza tonight. But for now, just focus on porting all your smart contracts over. All right, and again, don't leave. We haven't checked in yet. So this is the time to turn to those around you and forge partnerships and work together and whatnot. All right. Thanks, guys.